Sure, here's an overview of how the given code works. Flask application, app.py. 1. Flask setup. The Flask application is set up to serve the main HTML page. When you access the root URL it renders index.html from the templates directory. 2. Serving static files. Flask also serves static files like CSS and JavaScript from the static directory. HTML index.html. 1. HTML structure. The HTML file sets up the structure of the web page, including links to CSS for styling and the fit file parser library for parsing fit files. 2. File upload and button. It includes an input element for selecting a fit file and a button to trigger the parsing function. 3. Output area. A preformatted text element pre is used to display the parsed data. JavaScript app.js. 1. File input handling. When the button is clicked, the JavaScript function parseFitFile is called. 2. Reading the file. The function reads the selected fit file using the File Reader API. 3. Parsing the file. The fit file parser library is used to parse the file content into a readable format. 4. Displaying the data. The parsed data is then displayed in the preformatted text element on the web page. Style.css. 1. Styling. Basic CSS styling is provided to improve the appearance of the web page, including styling for the header, input, and button elements. Overall workflow. 1. User interaction. The user accesses the web page served by Flask, selects a fit file, and clicks the parse button. 2. Client-side processing. The selected file is read and parsed entirely on the client side using JavaScript. 3. Data display. The parsed data is displayed directly in the browser without the need for server-side processing of the file content. This setup allows for a simple, efficient way to handle and display fit file data using client-side processing, while Flask serves the necessary HTML, CSS, and JavaScript files.
Yeah, I also want the default file to be loaded from within the folder for the project. Maybe a data folder within the fit data project. So essentially, if the user doesn't have feed files, they can use this one.
To provide a default fit file that can be loaded if the user doesn't have their own file to upload, you can store the default file in a folder within your project and modify the JavaScript to load this file if no file is selected by the user. Directory structure: Garmin data app, flash, app.py, templates, index.html, static, j, app.js, CSS, style.css, data, default.fit. Flask application, Python from Flask and for Flask render template, send from directory app equals Flask at app.route slash. Def index, return render gore template index.html at app.route slash data slash path file name. Def download file name, return send from directory data file name. If or name equals score main, app.run debug true. HTML and JavaScript. Modify the JavaScript to check for a user uploaded file, and if none is found, load the default file from the server. Index.html doctying head meta charset UTF title Garmin data processor link rel style sheet URL for static file name equals css slash style.css scripts rc slash cdn.jsdeliver.net npm fit file parser dist fit parser.min body div app upload fit file a type file a file input button one click parse.
Can you from now on just generate instructions for another AI to do the coding? You would not be doing the coding. And so can we question why do we load the default file in the backend? The file is available in a data folder. Can we make it available to the user? So shouldn't that be loaded in JavaScript? We want to do as little as possible in the backend, in the Python code. Can even load it in HTML.
Absolutely. I'll provide instructions for another AI to write the code, focusing on minimizing backend work and loading the default file using JavaScript. Objective: create a Flask application that serves a single page application SPA. The SPA should allow users to upload a fit file and process it client-side using JavaScript. If no file is uploaded, a default fit file from the data folder should be used. Instructions for setting up the project. 1. Set up project structure. Create a project directory Garmin data app. Inside the directory, create the following subdirectories and files: Garmin data app slash app.py, templates slash index.html, static js slash app.js, css slash style.css, data, default.fit, venv. 2. Flask setup, app.py. Create a basic Flask application to serve the HTML and static files. Serve the index.html from the templates folder. Ensure the static folder is accessible for JavaScript and CSS files. No need to handle the default file in the backend. It will be served as a static file. 3. HTML file, index.html. Set up the basic HTML structure. Include an input element for file uploads. Add a button to trigger file parsing. Include a pre-element to display parsed data. Link to the style.css for basic styling. Link to the app.js for JavaScript logic. Include the fit file parser library via CDN. 4. JavaScript file appheap.js. Implement logic to handle file input and parsing. If a file is selected by the user, read and parse it. If no file is selected, fetch and parse the default fit file from the data folder. Use the fit file parser library to parse the fit file data. Display the parsed data in the pre-element. 5. CSS file, style.css. Add basic styling for the web page, including the header, input, and button elements. Hash detailed instructions for each step. Flask setup app.py. Initialize Flask application. Create a Flask instance. Define a route to serve the index.html file. 2. Serve static files. Ensure Flask serves static files from the static directory. HTML file index.html. 1. Basic structure. Include a doctype declaration. Set up HTML head and body sections. Add meta tags for character encoding. 2. Link CSS and JavaScript. Link to the style.css file in the static CSS directory. Link to the app.js file in the static JS directory. Include the fit file parser library via a CDN. 3. Input and output elements. Add an input type of file element for file uploads. Add a button to trigger file parsing. Add a pre-element to display the parsed data. JavaScript file app.js. 1. Handle file input. Add an event listener to the button to trigger the parsing function. 2. Read and parse file. Use the file reader API to read the selected file. If no file is selected, fetch the default file using fetch. 3. Parse fit data. Use the fit file parser library to parse the fit file data. Display the parsed data in the pre-element. CSS file style.css. 1. Basic styling. Style the body with a font family and margin. Style the header, input, and button elements. Example instructions for another AI. 1. Flask setup app.py. Python, create a Flask instance. Serve the index.html file from the templates folder. Ensure static files are accessible. 2. HTML file.html. HTML, set up basic HTML structure. Link to CSS and JavaScript files. Include fit file parser library via CDN. Add input and button elements for file upload. Add a pre-element to display parsed data. 3. JavaScript file app.js. JavaScript, add event listener to the button. Read the selected file or fetch the default file. Parse the fit file data using fit file parser. Display the parsed data in the pre-element. 4. CSS file style.css. CSS, style the body, header, input, and button elements. These instructions should guide another AI to implement the desired functionality, ensuring minimal backend processing and leveraging client-side processing for handling fit files.
Can you give a quick overview of the whole application, what it does, and how it can be used?
Overview of the application. The application is a single-page web application, SPA, built using Flask and vanilla JavaScript, designed to process Garmin fit files client-side. It allows users to upload a fit file for parsing and, if no file is uploaded, uses a default fit file stored in the project. Key features. 1. File upload. Users can upload their own fit files through an input element. 2. Default file. If no file is uploaded, the application uses a default fit file stored in the data folder. 3. Client-side processing. Fit files are read and parsed entirely on the client side using JavaScript and the fit file parser library. 4. Data display. Parsed data from the fit files is displayed on the web page. Application structure. Flask backend serves the HTML, CSS, and JavaScript files and makes the default fit file available as a static file. HTML provides the structure for the web page, including input elements for file uploads and a display area for parsed data. JavaScript handles file reading and parsing using the File Reader API and Fit File Parser library. CSS provides basic styling for the web page elements. How to use the application. 1. Access the web page. Open the web page served by the Flask application. 2. Upload a fit file. Use the file input element to select and upload a fit file from your computer. 3. Parse the file. Click the Parse button to read and parse the selected fit file. 4. View parsed data. The parsed data will be displayed in the preformatted text area on the web page. 5. Default file handling. If no file is uploaded, the application automatically fetches and parses the default fit file from the data folder. How it works. 1. Flask server serves the index.html file from the templates folder and static files CSS.js from the static folder. Makes the default fit file available through a specific route. 2. HTML and CSS. The HTML file includes an input for file uploads, a button to trigger parsing, and a pre-element to display the parsed data. CSS provides basic styling for a clean and simple user interface. 3. JavaScript. Listens for the button click event to trigger the parsing function. Uses the File Reader API to read the uploaded file or fetches the default file if none is uploaded. Parses the fit file using the fit file parser library and displays the data in the pre-element. Benefits: user-friendly, simple interface for uploading and parsing fit files. Client-side processing reduces server load by processing files on the client side. Fallback mechanism provides a default fit file for users who do not have their own files to upload. This overview provides a clear picture of the application's purpose, structure, and usage, ensuring ease of understanding and implementation.
Yeah, there's some sort of folder issue, isn't it? Is it? Yeah, maybe this parsefit app file should not be called anywhere. Regenerate the project file and folder. And this is better. Right, this is correct. Yeah, this will won't work with the phone. To reload this page, do I? Yeah, that's the problem. I don't know why on the website they are missing most of the functionality. That's not cool. As opposed to the app. Okay, now it's working, maybe. Maybe not. Maybe not. Okay, this is annoying. This is very annoying. Switching between models is nice. Still doesn't work though. Bum, bum, bum. Yeah, trying the camera on the phone. It's working on the phone, so it won't work in the browser anymore. Ba-bow. We have the good voice coming through though.
Observations from the images. There are a few issues. 1. JavaScript errors. Reference error. Exports is not defined. This indicates an issue with how the fit file parser library is being used in a browser context. Type error. Fit parser is not a constructor. This suggests that the fit parser class might not be correctly imported or used. 2. Directory structure. Your directory structure looks correct with the data folder containing the default fit file and appropriate directories for static files. Instructions to resolve the issues. To resolve these issues and ensure the application works correctly, follow these steps. 1. Include the correct version of the fit file parser library. Make sure you are using a version of the fit file parser library that is compatible with browser environments. If the library you are using is intended for Node.js, it won't work directly in the browser. Number 2, modify JavaScript to load the library correctly. If the current library does not support direct inclusion in the browser, consider using a different library or approach. Updated instructions. 1. Download and include a browser-compatible fit file parser. Use a library like Browserify to bundle the fit file parser library for browser use, or find an alternative that works directly in the browser. 2. Correct the JavaScript code. Ensure the library is included correctly and the fit parser is instantiated properly. Steps for another AI to implement. 1. Check library compatibility. Ensure that the fit file parser library is compatible with browser environments. If not, bundle it using tools like Browserify. 2. Modify javascript.js. Ensure the library is correctly included and used in the script. 3. Example of correcting library import. If the library needs to be bundled, include the bundled version correctly. 4. Ensure event listener is correctly attached. Verify that the event listener is properly attached to the button in the HTML. Instructions to another AI. 1. Verify library compatibility. Check if the fit file parser library is compatible with browser environments. If not, bundle the library using Browserify or find an alternative. 2. Modify index.html. Ensure the correct version of the fit file parser library is included. 3. Modify app.js. Ensure the fit parser class is correctly instantiated. Ensure event listeners are correctly attached. 4. Test the application. Load the page and ensure the fit file can be uploaded and parsed. Test with both user-uploaded files and the default file. By following these steps, the issues should be resolved and the application should function correctly, processing fit files on the client side.
Okay, based on these instructions, can you generate all the necessary code without any placeholders? Yeah, seems like GitHub Copilot can't handle this. It's too much. Way too much for it. Let's see if this bot can just do the job.
Sure. Here's the complete set of instructions and code to ensure the application works correctly with client-side processing of fit files. The instructions assume using the fit file parser library compatible with browser environments. Updated code for Flask application with client-side processing. 1. Flask setup, app by. app.py, Python from Flask, import Flask, render template app equals Flask at app.route, def index. Return render template index.html. If name main app.run debug true. 2. HTML files.html, index.html, HTML doctype HTML meta charset UTF title Garmin data processor, link rel style sheet trefcals, URL for static file name equals css/style.css. Scripts are cdn.jsdeliver.net /fitfile parser /dist fitparser.mint head. Div id equal app upload fit file. Input type file I'd file input. Button on click parse fit file, parse output. Script star equals URL for static, file name equals app.js. 3. JavaScript file.js, app.js JavaScript function parse fit file. Const file input equals document.get element by ID file input. Const file equals file input.file0. Const output element equals document.get element by ID output. If file, read file, else fetch default file. Function read file, const reader equals new file reader. Reader.onload equals function event. Const array buffer equals event target result. Parse fit data array buffer. Reader.read as array buffer file. Function fetch default file.
I have trouble with the Ava device reading out loud. No, still doesn't work. Still doesn't work. Right, now it's working. Yeah. Had to close the chat on the phone. Okay, all that is so we don't have to upload, so the user doesn't have to upload the feed files onto the server. Seems a lot to handle just for that.
The fit file parser library you are using is designed for Node.js and not for browser environments. This is why you are encountering the reference error, exports is not defined error. To resolve this, you can use a browser-compatible version of the library or bundle the library for browser use. One way to do this is to use a bundler like Browserify. Instructions to bundle fit file parser for browser. Use 1. Install Browserify. If you haven't already, install Browserify globally. sh npm install-g Browserify. 2. Create a bundled version of fit file parser. Create a JavaScript file, bundle.js, that requires the fit file parser. JavaScript const fit parser equals require fit file parser. Window fit parser fit parser. Use Browserify to bundle this file for browser use. Browserify bundle.js -o statics.js/fit parser.bundle.js. 3. Update your HTML to use the bundled version. Modify your index.html to include the bundled fit parser library. Updated instructions for another AI to implement. 1. Create the bundle.js file. JavaScript const fit goals require fit file parser. Window.fitParser fit parser. 2. Use Browserify to bundle the file. Browserify bundle.js static.js/fit parser.bundle.js. 3. Update index.html. Replace the CDN link with the bundled version. HTML script static.js fit parser.bundle. Revised code for browser compatibility. 1. Create bundle.js. JavaScript const fit parser require fit file parser. Window.fitParser fit parser. 2. Bundle with Browserify. Run the following command in your project directory: browserify bundle.js -o static.js fit parser.bundle.js. 3. Update index.html. HTML doctype HTML, metacharset UTF-8, Garmin data processor, link rel style sheet, URL for static.
Okay, we'll have to continue this next time. Yeah, lots of problems on the get-go. But yeah, apparently we can just download the JavaScript from the CDN. That in theory should solve the problem. Yep, should be straightforward. And let's do it quickly. Oops. The fit parser save as data static JavaScript save. Okay, we have that. Now we have an updated HTML. Fit pass mean JS. And what's that? What? But just a general note. I cannot review if you send me files in email or direct or private messaging, whatever, because they have to be in the public domain. Because if you have any personal information in the file, whatever, I just don't want to be liable for it getting out there. And I do want to use the data on YouTube, on my website, which is all public domain. So if you want me to look at any data files, just pop them onto any public repository, GitHub, anything pretty much. I have an extensive list on my website where potentially you can pop your dataset in. It's pretty much any of those. Here, looking at Figshare, research does Nodo, Physionet, IEG, Kaggle dataset, Google dataset. I don't know if you. No, those. Anyway, it needs to be in the public domain, so anyone can access. That will make sure that you de-identify the data correctly. And we will continue this one next time. See you in a bit. Bye.